Okay, this is our video series on special products, and what I want to look at in this video clip is something called the sum of two cubes or the difference of two cubes. Okay, so this is basically the outcome of a product. To achieve this outcome, your components that you're going to multiply together, folks, must take on a particular form. Okay, let's see what they should look like. You should have a binomial multiplied by a trinomial, but not just any trinomial. The trinomial must consist of the following. It must consist of the square of the first term and the square of the last term over there. And in the middle, be careful now, you just want that product over there, the AB, not multiplied by 2. So there's a plus there, and then this is negative. Let's look at what I mean. Well, if you have x plus 2, and in this bracket you must have these terms in that form. X squared minus 2 times x is 2x, plus the last one squared. If that's the case, if this is the form of the second bracket, then you merely have to say it's this term cubed plus that term cubed. So this result will be x cubed plus 8. Here it will be a cubed plus b cubed. The first one cubed plus the second one cubed. But it has to be in that form. It has to be in this form here. This is very important. So let's practice forming things that are in that form. If I have an x minus a 3 here, let's go back here. If we have a minus a b, then the only thing is your second bracket will only have positives in it. So if there's a minus here, there's a positive there and a positive there. Okay, so I want to form this bracket so that the outcome is x cubed minus 3 cubed, which is 27. So what must have been in this bracket? Let's see. Must be the first term squared, so there has to be an x squared. There's a minus, so this has to be a plus. 3 times x is 3x. Okay, not times by 2. I'm not squaring a binomial here. Okay, and then the last term squared. So that's what must have been in this bracket for this product to be as simple as that. Okay, let's go for 2x minus or plus 1, where there's coefficients in front of the x's. In this bracket, I must have, if I want this to be 2 to the power 3 is 8, x cubed plus 1. If that is the result, then this must take on that form. Okay, so it has to be this first term squared, which is 4x squared minus, because there's a plus, 2x, and then plus 1. Okay. So let's have a look at a few problems where I've got these two and I've got to get there. I hope you can identify this form. So let's go for x plus 5 multiplied by x squared minus 5x plus 25. Now let's see. The first term squared, the second must be the negative of that product, which it is, and the third term must be the first one squared. Then the result is that cubed plus the 5 cubed, which is 125. If this had been x plus 5, x squared plus 5x plus 25, let's have a look. There's an x squared, there's a plus, so this should be a minus. So, it is not going to become the sum of two cubes. I now need to do term by term multiplication. So the x goes into the bracket. X times x squared is x cubed. I have to distribute. It's not a special case. x times 5x is 5x squared. X times 25 is 25x plus 5x squared. 5 times that is plus 25x. 5 times this one is plus 125. We clean it up. X cubed, there's a x squared, so plus 10x squared. 25 plus 25 is 50x plus 125. So you can see they look very different, folks. And the reason why they look different is this one had a minus, which was in that form, and this one did not. If this was a minus, then this would have worked as x cubed minus 125. So look for the form and look carefully. Okay, there's a few nice problems or questions that we can ask you on this that expands your knowledge a little bit more. So let me try and find one here that challenges you a bit. You get a nice one where we actually work with fractions. Okay, so let's see. I've got to have an outcome that is the sum of one thing cubed multiplied by the next thing cubed. So let's look at x over 4 minus y over 3. Now you'll notice that I've got x's and y's. Okay? This needs to be multiplied by x squared over 16 plus xy over 12 plus y squared over 9. And that again has to be multiplied by x over 4 plus y over 3 multiplied by x squared over 16 minus xy over 12 plus y to the power of 2 over 9. It's an ugly problem, but if you look at forms, if you know your forms, your life is going to be very easy. Let's have a look. This is a by times a try, another by times a try. If I look at those two, yes, they're the difference of squares. I like them. They are the difference of squares. But then, what am I going to do with this? So let's rather look for a by times a try form. If, remember what does it say? If it is a minus b, then this must be a squared plus ab plus b squared. Let's see if it is. X over 4 squared is x squared over 16. X over 4 times y over 3 is xy over 12. And here is the square of the second term. So that combination gives you x over 4 cubed minus y over 3 cubed as a result. Now this here, I'm going to use a curly bracket, must now multiply with the outcome of that product. Now if we look at this, these two brackets are identical. Those as well. That's a minus, a plus. We don't care about that. We care about that being a plus and this a minus, because then it's the same product, just with a plus. So this flushes out, or distributes, flushes out, distributes as this to the power 3 plus y over 3 to the power 3. You can see clearly that squared is there. This times that with a negative in front is in the middle, and the last one squared is over there. Okay, so what do we have? We have a minus b times a plus b. Can you see the form, folks? The form is important. This has now just become a minus b, which I multiply with a plus b, which is indeed the difference of two squares. So this ugly sum reduces to almost nothing. This becomes the first one squared. Now the first term is x over 4 cubed, and we're going to square it, minus the second term y over 3 cubed, and that term has to square. Okay, so just basic exponential law that I'm going to show you quickly. If you have a number p and you raise it to a power of m, and you raise that power to another power n, then your result will be the P and the product of the powers is the new power. So here we have x over 4 to the power of 6 minus y over 3 to the power of 2 times 3, which is 6. Okay, and that's it. What a beautiful question, what a nice application to the sum and the difference of two cubes. Always remember, folks, this is what you've got to remember. If that is the form of the two things you're multiplying, there's a shortcut. You don't want to waste time distributing term by term and cleaning it up afterwards. You don't have the luxury of time in a test or in an exam. Okay, if that meant something to you, please like the video and also then subscribe to the channel.